P says that no members of the class S are members of the class P, that is, there are no things that belong to both classes. This can be rephrased by saying that the product of the two classes is empty, which is symbolized by the says that at least one member of S is also a member of P. This means that the product of the classes S and P is not empty and is symbolized by the inequality SP is not equals to 0. To symbolize A and O propositions, it is convenient to introduce a new method of representing class complements. The complement of a class is the collection or class of all things that do not belong to the original class as explained in section 5.6. The complement of the class of all soldiers in the class of all things that are not soldiers. The class of all non-soldiers, where the letter S symbolizes the class of all soldiers. We symbolize the class of all non-soldiers by S. Read S bar, the symbol for the original class with a bar above it. The A proposition all S is P says that all members of the class S are also members of the class P, that is, there are no members of the class S that are not members of P, or by a version that no S is non-P. This, like any other E proposition, says that the product of the class is designated by its subject and predicate terms is empty. It is symbolized by the equation SP bar is equal to 0. The O proposition sum S is not P obeys to the logically equivalent I proposition sum S is non-P, which is symbolized by the inequality SP bar is not equals to 0. In their symbolic formulations, the interrelations among the four standard form categorical propositions appear very clearly. It is obvious that the A and O propositions are contradictories when they are symbolized as SP bar is equal to 0 and SP is not equal to 0, and it is equally obvious that the E and I propositions SP equal to 0 and SP is not equal to 0 are contradictories. The Boolean square of opposition may be represented as shown in the figure. The notation shown in the table is useful, for example, in representing the relationship among the contradictories in the Boolean square of opposition. When first explaining the four types of standard form categorical propositions in section 5.3, we represented the relations of the classes in those propositions graphically with intersecting circles labeled S and P. Now we carry that process of diagramming categorical propositions somewhat further, enriching our notation in ways that will facilitate the analysis to follow. We begin by representing any class with an unmarked circle labeled with a term that designates that class. The class S is diagrammed with a simple circle. So, symbolic representation of categorical propositions. Form A, proposition all S is P, symbolic representation SP bar equal to 0. Explanation, the class of things that are both S and non-P is empty. Form E, proposition no S is P, symbolic representation SP equal to 0. Explanation, the class of things that are both S and P is empty. Form I, proposition sum S is P, symbolic representation SP is not equal to P. The class of things that are both S and P is not empty. SP has at least one member. Form O, sum S is not P, symbolic representation SP bar is not equal to 0. Explanation, the class of things that are both S and non-P are not empty. SP bar has at least one member. The diagram in figure 5.3 is of a class, not a proposition. It represents the class S, but it says nothing about it. To the diagram, the proposition that S has no members or that there are no S's, we shade all of the interior of the circle representing S, indicating in this way that it contains nothing and is empty. To diagram the proposition that there are S's, which we interpret as saying that there is at least one member of S, we place in X anywhere in the interior of the circle representing S, indicating in this way that there is something inside it, that it is not empty. Thus the two propositions there are no S's and there are S's are represented by the two diagrams. Note that the circle that diagrams the class S will also in effect diagram the class S bar, for just as the interiors of the circle represent all members of class S, so the exterior of the circle represent all members of S bar. To diagram a standard form categorical proposition as explained in section 5.3, two circles are required. Figure 5.5 shows a pair of intersecting circles, which means used as the skeleton or framework for diagramming any standard form categorical proposition whose subject and predicate terms are symbolized by S and P. Figure 5.5, two diagrams are classes S and P but diagrams no proposition concerning them. It does not affirm that either or both have members, nor does it deny that they have. In fact, there are no more than two classes diagrammed by the two intersecting circles. The part of the circle labeled S that does not overlap the circle labeled P diagrams all S's that are not P's and can be thought of as a representing the product of the classes S and P. We may label it SP. The overlapping part of the two circles represent the product of the classes S and P and diagrams all things belonging to both of them. It is labeled SP. The part of the circle labeled P that does not overlap the circle labeled S diagrams all P's that are not S's and represents the product of the class S and P. It is labeled SP, S bar P finally. The part of the diagram external to both circles represent all things that are neither in S nor in P. It diagrams the fourth class S bar P bar so labeled with these labels inserted. Figure 5.5 becomes figure 5.6. Figure 5.6 can be interpreted in terms of several different classes determined by the class of all Spaniards and the class of all painters P. SP is the product of these two classes containing all those things and only those things that belong to both of them. Every member of SP must be a member of both S and P. Every member must be both a Spaniard and a painter. This product class SP is the class of all Spanish painters which contains among others Velázquez and Goya. SP bar is the product of the first class and the complement of the second, containing all those things that only those things that belong to the class S but not to the class P. It is the class of all Spaniards who are not painters, all Spanish non-painters, and it will contain neither Velázquez or nor Goya, but it will include both the novelist Cervantes and the detective Franco, among many others. S bar P is the product of the second class and the complement of the first, and is the class of all painters who are not Spaniards. This class S bar P of all non-Spanish painters include among others both the Dutch painter Rembrandt and the American painter Georgia O'Keeffe. Finally, S bar P bar is the product of the complements of the two original classes. It contains all those things and only those things that are neither Spaniards nor painters. It is a very large class indeed, containing not merely English admirals and Swiss mountain climbers, but such things as the Mississippi River and the Mount Everest. All these classes are diagrammed in figure 5.6 by the letters S and P interpreted as in this paragraph. Diagrams of this kind, as noted earlier, are called Venn diagrams after John Venn, the English logician who introduced this notation. When in such diagrams their several areas are labeled but not marked in any other way, they represent classes only. Figure 5.6 illustrates this. It does not represent any proposition. In such a diagram, if a circle or a part of a circle is blank, that signifies nothing, neither that there are not members of the class represented by that space. With certain additions, however, Venn diagrams can be used to represent propositions as well as classes by shading out some spaces or by inserting x's in various parts of the picture. We can accurately diagram any one of the four standard form categorical propositions. Because Venn diagrams with appropriate markings represent categorical propositions so fully and so graphically, these diagrams have become one of the most powerful and most widely used instruments for the appraisal of syllogistic arguments. Let us consider how each of the four basic categorical propositions can be represented using this technique. To diagram the A proposition, all SSP symbolized by SP bar is equal to 0, we simply shade out the part of the diagram that represents the class SP bar, thus indicating that it has no members or is empty. To diagram the E proposition, no SSP symbolized by SP equals to 0, we shade out the part of the diagram that represents the class SP to indicate that it is empty. To diagram the I proposition, some SSP symbolized by SP is not equal to 0, we insert an X into the part of the diagram that represents the class SP. This insertion indicates that the class product is not empty but has at least one member. Finally, for the O proposition, sum S is not be symbolized by SP bar is not equal to 0, we insert an X into part of the diagram that represents the class SP bar to indicate that it is not empty but it has at least one member. Place side-by-side diagrams for the four standard form categorical propositions display their different meanings very clearly. We have constructed diagrammatic representations for no SSP and some SSP, and because they are logically equivalent to their converses, no P is S and some P is. The diagrams for the latter have already been shown. Diagram of the A proposition, all P is S, symbolized by PS bar O equals to 0 within the same framework. We must shade out the part of the diagram that represents the class PS bar. It should be obvious that the class PS bar is the same as the class S bar P. If not immediately, then by recognizing that every object that belongs to the class of all painters and the class of all non-Spaniards must also belong to the class of all non-Spaniards and the class of all painters. All painting non-Spaniards are non-Spanish painters and vice versa. To diagram the proposition, some P is not less symbolized by PS bar equals to 0. Insert an X into the part of the diagram that represents the class PS bar, that is S bar P. Diagrams for these propositions then appear later. This for the adequacy of the two circle diagrams is mentioned because in the next chapter it will be important to be able to use a given pair of overlapping circles with given labels, says S and M, to diagram any standard form categorical proposition containing S and M as its terms regardless of the order in which they occur in it. The Venn diagrams constitute the iconic representation of the standard form categorical propositions in which spatial inclusions and exclusions correspond to the non-spatial inclusions and exclusion of classes. They provide an exceptionally clear method of notation. They also provide the basis for the simplest and most direct method of testing the validity of categorical syllogisms. It will be explained in chapter 6. Exercises: express each of the following propositions as equalities or inequalities, representing each class by the first letter of the English term, designating it, and symbolizing the proposition by means of a Venn diagram. Example: some sculptors are painters. Solution by drawing a diagram. So second is no peddlers are millionaires. Third is all merchants are speculators. Fourth is some musicians are not pianists. Fifth is no shopkeepers are members. Sixth is some political leaders of high reputation are scoundrels. Seventh is all physicians licensed to practice in the state or medical school graduates who have passed special qualifying examinations. Eighth is some stockbrokers who advise their customers about making investments are not partners in companies or securities they recommend. Ninth is all Puritans who reject all useless pleasure or strangers too much that makes life worth living. 10th is no modern paintings are photographic likeness of their objects. 11th is some student activists are middle-aged men and women striving to recapture their lost youth. 12th is all medieval scholars are pious monks living in monasteries. 13th is some state employees are not public spirited citizens. 14th is no magistrate subject to election and recall will be punitive tyrants. 15th is some patients exhibiting all the symptoms of schizophrenia have bipolar disorder. 16th is some passengers on jet airplanes are not satisfied customers. 17th is some priests are militant advocates of radical social change. 18th is some stalwart defenders of the existing order and are not members of a political party. 19th is no pipeline laid across foreign territories are safe investments. 20 is all pornographic films are menaces to civilization and decency. So with this we end our chapter 5 and unit 2. 5.6 Further immediate inferences. There are three other important kinds of immediate inference: conversion, obversion, and contraposition. These are not associated directly with the square of opposition. Each is explained below. Conversion is an inference that proceeds by interchanging the subject and predicate terms of a proposition. No men are angel converts to no angels are men, and these propositions may be validly inferred from one another. Similarly, some women are writers and some writers are women are logically equivalent, and by conversion, either can be validly inferred from the other. Conversion is perfectly valid for all E and for all I propositions. One standard form categorical proposition is said to be the converse of another when we derive it by simply interchanging the subject and predicate terms of that other proposition. The proposition from which it is derived is called convertant. Thus, no idealists are politicians is the converse of no politicians are idealists, which is its convertant. The conversion of an O opposition is not valid. The O proposition, some animals are not dogs, is plainly true. Its converse is the proposition, some dogs are not animals, which is plainly false. And O proposition and its converse are not logically equivalent. The A proposition presents a special problem here. Of course, the converse of an A proposition does not follow from its convertant. From all dogs are animals, we certainly may not infer that all animals are dogs. Traditional logic recognized this, of course, but asserted nevertheless that something like conversion was valid for A propositions. On the traditional square of opposition, one could validly infer from the A proposition, all dogs are animals. Its subaltern I proposition, some dogs are animals. The A proposition says something about all members of the subject class, dogs. The I proposition makes a more limited claim about only some of the members of that class. It was held that one could infer some SSP from all SSP, and as we saw earlier, an I proposition may be converted validly. If some dogs are animals, then some animals are dogs. So if we are given the A proposition, all dogs are animals, we first infer that some dogs are animals by subalternation, and from that subaltern we can by conversion validly infer that some animals are dogs. Hence, by a combination of subalternation and conversion, we advance validly from all SSP to some P is S. This pattern of inference, called conversion by limitation or conversion per accidents, proceeds by interchanging subject and predicate terms and changing the quantity of the proposition from universal to particular. This type of conversion will be considered further in the next section. In all conversions, the converse of a given proposition contains exactly the same subject and predicate terms as the convertant, their order being reversed, and always has the same quality of affirmation or denial. A complete picture of this immediate inference, as traditionally understood, is given by the following table. So the convertend is A, all S is P, and the converse will be I proposition, some P is S by limitation. If the convertend is E proposition, no S is P, then the converse will be E proposition, no P is S. If the convertend is I proposition, some S is P, then the converse will be I proposition, some P is S. If the convertend is O proposition, some S is not P, the conversion not valid. So conversion, in simple terms, a valid form of immediate inference for some but not all types of propositions. To form the converse of a proposition, the subject and predicate terms are simply interchanged. Thus, applied to the proposition no circles are squares, conversion yields no squares are circles, which is called the converse of the original proposition. The original proposition is called the converted. B. Classes and class complements. So now let's come to the next topic. To explain other types of immediate inference, we must examine more closely the concept of a class and explain what is meant by the complement of a class. Any class, we have said, is the collection of all objects that have a certain common attribute, which we may refer to as the class-defining characteristic. The class of all humans is the collection of all things that have the characteristic of being human. Its class-defining characteristic is the attribute of being human. The class-defining characteristic need not be a simple attribute. Any attribute may determine a class. For example, the complex attribute of being left-handed and red-headed and a student determines a class, the class of all left-handed red-headed students. Every class has associated with it a complementary class or complement, which is the collection of all things that do not belong to the original class. The complement of the class of all people in the class of all things that are not people. The class-defining characteristic of that complementary class is the negative attribute of not being a person. The complement of the class of all people contains no people, but it contains everything else. Shoes and ships and sealing wax and cabbages, but no kings, because kings are people. It is often convenient to speak of the complement of the class of all persons as the class of all non-persons. The complement of the class designated by the term S is then designated by the term non-S. We may speak of the term non-S as being the complement of the term S. Sometimes in reasoning, one uses what is called the relative complement of a class. Its complement within some other class. For example, within the class of children of mine, there is a subclass, daughters of mine, whose relative complement is another subclass, children of mine who are not daughters, or sons of mine. But aversions and other immediate inferences rely on the absolute complement of classes as defined above. The word complement is thus used in two senses. In one sense, it is the complement of a class. In the other, it is the complement of a term. These are different but very closely connected. One term is the term complement of another, just in case the first term designates the class complement of the class designated by the second term. Note that the class is the class complement of its own complement. Likewise, a term is the term complement of its own complement. A sort of double negative rule is involved here to avoid strings of nons prefixed to a term. Thus, the complement of the term voter is non-voter, but the complement of non-voter should be simply written as voter rather than as non-voter. One must be careful not to mistake contrary terms for complementary terms. Coward and hero are contraries because no person can be both a coward and a hero. We must not identify cowards with non-heroes because not everyone and certainly not everything need be one or the other. Likewise, the complement of the term winner is not loser but non-winner. For although not everything or even everyone is either a winner or a loser, absolutely everything is either a winner or a non-winner. So complement or complementary class, the collection of all things that do not belong to a given class. And aversion, a valid form of immediate inference for every standard form categorical proposition. To obvert a proposition, we change its quality from affirmative to negative or from negative to affirmative and replace the predicate term with its complement. Thus, applied to the proposition, all dogs are mammals, aversion yields no dogs are non-mammals, which is called the obverse of the original proposition. The original proposition is called the avertant. So obversion is an immediate, now next topic is obversion. Obversion is an immediate inference that is easy to explain once the concept of a term complement is understood. To obvert a proposition, we change its quality, affirmative to negative or negative to affirmative, and replace the predicate term with its complement. However, the subject term remains unchanged, and so does the quantity of the proposition being obverted. For example, the A proposition, all residents are voters, has as its obverse the E proposition, no residents are non-voters. These two are logically equivalent propositions and neither may be validly inferred from the other. Obversion is a valid immediate inference when applied to any standard form categorical proposition. The E proposition, no umpires are partisans, has its obverse the logically equivalent A proposition, all umpires are non-partisans. The I proposition, some metals are conductors, has its obverse the O proposition, some metals are not non-conductors. The O proposition, some nations were not belligerents, has its obverse the I proposition, some nations were non-belligerents. The proposition serving as premise for the obversion is called the obvertent. The conclusion of the inference is called the obverse. Every standard form categorical proposition is logically equivalent to its obverse. So obversion is a valid form of immediate inference for all standard form categorical propositions. To obtain the obverse of any proposition, we leave the quantity, universal or particular, and the subject term unchanged. We change the quality of the proposition and replace the predicate term with its complement. The following table gives a complete picture of all valid obversions. Obvertent A proposition, all S is P. Obverse E proposition, no S is non-P. Obvertent E proposition, no S is P. Obverse A proposition, all S is non-P. Obvertent I proposition, some S is P. Obverse O proposition, some S is not non-P. Obvertent O proposition, some S is not P. Obverse I proposition, some S is non-P. D. Next topic is contraposition. Another type of immediate inference, contraposition, can be reduced to the first two, conversion and obversion, to form the contrapositive of a given proposition. We replace its subject term with the complement of its predicate term, and we replace its predicate term with the complement of its subject term. Neither the quality nor the quantity of the original proposition is changed. So the contrapositive of an A proposition is an A proposition, the contrapositive of an O proposition is an O proposition, and so forth. For example, the contrapositive of the A proposition, all members are voters, is the A proposition, all non-voters are non-members. These are logically equivalent propositions, as will be evident on reflection. Contraposition is plainly a valid form of immediate inference when applied to A propositions. It really introduces nothing new because we can get from any A proposition to its contrapositive by first obverting it, next applying conversion, and then applying obversion again. Beginning with all S is P, we obvert it to obtain no S is non-P, which converts validly to no non-P is S, whose obverse is all non-P is non-S. The contrapositive of any A proposition is the obverse of the converse of the obverse of that proposition. Contraposition is a valid form of immediate inference when applied to O propositions also, although its conclusion may be awkward to express. The contrapositive of the O proposition, some students are not idealists, is the somewhat cumbersome O proposition, some non-idealists are not non-students, which is logically equivalent to its premise. This also can be shown to be the outcome of first obverting, then converting, then obverting again. Some S is not P obverts to some S is non-P, which converts to some non-P is S, which obverts to some non-P is not non-S. For I propositions, however, contraposition is not a valid form of inference. The true I proposition, some citizens are non-legislators, has as its contrapositive the false proposition. Some legislators are non-citizens. The reason for this invalidity becomes evident when we try to derive the contrapositive of the I proposition by successively obverting, converting, and obverting the obverse of the original I proposition, some S is P, is the O proposition, some S is not non-P. But as we saw earlier, the converse of an O proposition does not follow validly from it. In the case of E propositions, the contrapositive does not follow validly from the original, as can be seen when, if you begin with true proposition, no wrestlers are weaklings. We get as its contrapositive the obviously false proposition, no non-weaklings are non-wrestlers. The reason for this invalidity we will see again if we attempt to derive it by successive obversion, conversion, and obversion. If we begin with the E proposition, no S is P, and obvert it, we obtain the A proposition. all S is non-P, which in general cannot be validly converted except by limitation. If we do then convert it by limitation to obtain some non-P is S, we can avert this to obtain some non-P is not some non-P is not non-S. This outcome we may call the contrapositive by limitation, and this too we will consider further in the next section. Contraposition by limitation, in which we infer an O proposition from an E proposition. For example, we infer some non-P is not non-S from no S is P, has the same peculiarity as conversion by limitation, on which it depends. Because a particular proposition is inferred from a universal proposition, the resulting contrapositive cannot have the same meaning and cannot be logically equivalent to the proposition that was the original premise. On the other hand, the contrapositive of an A proposition is an A proposition, and the contrapositive of an O proposition is an O proposition, and in each of these cases, the contrapositive and the premise from which it is derived are equivalent. Contraposition is thus seen to be valid only when applied to A and O propositions. It is not valid at all for I propositions, and it is valid for E propositions only by limitation. The complete picture is exhibited in the following table. Premise, A proposition, all S is P. Contrapositive, A proposition, all non-P is non-S. Premise, E proposition, no S is P. Contrapositive, O proposition, some non-P is not non-S by limitation. Premise, I proposition, some S is P. Contraposition not valid. Premise, O proposition, some S is not P. Contrapositive, O proposition, some non-P is not non-S. Questions about the relations between propositions can often be answered by exploring the various immediate inferences that can be drawn from one or the other of them. For example, given that the proposition all surgeons are physicians is true, what can we know about the truth or falsehood of the proposition? No non-surgeons are non-physicians. Thus, this problematic proposition or its contradictory or contrary follow validly from the one given as true. To answer, we may proceed as follows. From what we are given, all surgeons are physicians, we can validly infer its contrapositive. All non-physicians are non-surgeons. From this, using conversion by limitation valid according to the traditional view, we can derive some non-surgeons are non-physicians, but this is the contradictory of the proposition in question. No non-surgeons are non-physicians, which is thus no longer problematic but known to be false. In the very first chapter of this book, we noted that a valid argument whose premises are true must have a true conclusion, but also that a valid argument whose premises are false can have a true conclusion. Thus, from the false premise, all animals are cats, the true proposition, some animals are cats, follows by subordination. Then, from the false proposition, all parents are students, conversion by limitation yields the true proposition, some students are parents. Therefore, if a proposition is given to be false and the question is raised about the truth or falsehood of some other related proposition, the recommended procedure is to begin drawing immediate inferences from either. First, the contradictory of the proposition known to be false, or second, the problematic proposition itself. The contradictory of a false proposition must be true, and all valid inferences from that will also be true propositions. If we follow the other course and are able to show that the problematic proposition implies the proposition that is given as false, we know that it must itself be false. Here follows a table in which the forms of immediate inference, conversion, aversion, and contraposition are fully displayed. So, immediate inferences, first is conversion. Convertant, A, all S is P. Converse will be some P is S. Obvertant, A proposition, all S is P. Obverse is no S is non-P. Contraposition, A proposition, premise, all S is P. Contrapositive, A, all non-P is non-S. Convertant, E proposition, no S is P. Converse, no P is S. Obvertant, no S is P. Obversion, all S is obversion, A proposition, all S is non-P. Premise, no S is P. Contrapositive, O proposition, some non-P is not non-S by limitation. Convertant, I proposition, some S is P. Converse, some P is S. Obvertant, some S is P. Obversion, O proposition, some S is not P. Premise, some S is P. Contrapositive, not valid. Convertant, some S is not P. O proposition. Converse, conversion not valid. Obvertant, some S is not P. Obversion, I proposition, some S is non-P. Premise, some S is not P. Contrapositive, O proposition, some non-P is not non-S. So contraposition, in simple terms, a valid form of immediate inference for some but for not all type of propositions. To form the contrapositive of a given proposition, its subject term is replaced by the complement of its predicate term, and its predicate term is replaced by the complement of its subject term. Thus, the contrapositive of the proposition all humans are mammals is the proposition all non-mammals are non-humans. Exercises. A. State the converses of the following proposition and indicate which of them are equivalent to the given proposition. First, no people who are considerate of others are reckless drivers who pay no attention to traffic regulations. Second, all graduates of West Point are commissioned officers in the US Army. Third, some European cars are overpriced and underpowered automobiles. Fourth, no reptiles are warm-blooded animals. No reptiles are warm-blooded animals. Fifth, some professional wrestlers are elderly persons who are incapable of doing an honest day's work. B. State the opposites of the following propositions. First, some college athletes are professionals. Second, no organic compounds are metals. Third, some clergy are not abstainers. Fourth, no genuses are conformists. Fifth, all objects suitable for boat anchors are objects that weigh at least 15 pounds. Exercise C. State the contrapositives of the following proposition and indicate which of them are equivalent to the given proposition. First, all journalists are pessimists. Second, some soldiers are not officers. Third, all scholars are non-degenerates. Fourth, all things weighing less than 50 pounds are objects not more than 4 feet high. Fifth, some non-citizens are non-residents. Fifth, some non-citizens are not non-residents. Exercise D. If all socialists are pacifists is true, what may be inferred about the truth or falsehood of the following propositions? That is, which can be known to be true, which can be known to be false, and which are undetermined. First, some non-pacifists are non-socialists. Second, no socialists are non-pacifists. Third, all non-socialists are non-pacifists. Fourth, no non-pacifists are socialists. Fifth, no non-socialists are non-pacifists. Sixth, all non-pacifists are non-socialists. Seventh, no pacifists are non-socialists. Eighth, some specialists are non-pacifists. Ninth, all pacifists are socialists. 10th, some non-pacifists are socialists. Exercise E. If no scientists or philosophers is true, then what may be inferred about the truth or falsehood of the following propositions? That is, which can be known to be true, which can be known to be false, and which are undetermined. First, no non-philosophers are scientists. Second, some non-philosophers are not non-scientists. Third, all scientists are non-philosophers. Fourth, no scientists are non-philosophers. Fifth, no non-scientists are non-philosophers. Sixth, all philosophers are scientists. Seventh, some non-philosophers are scientists. Eighth, all non-philosophers are non-scientists. Ninth, some scientists are non-philosophers. No philosophers are non-scientists. Exercise F. If some saints were martyrs is true, what may be inferred about the truth or falsehood of the following propositions? That is, which can be known to be true, which can be known to be false, and which are undetermined. First, all saints were martyrs. Second, all saints were non-martyrs. Third, some martyrs were saints. Fourth, no saints were martyrs. Fifth, all martyrs were non-saints. Sixth, some martyrs were saints. Seventh, some saints were not non-martyrs. Eighth, no martyrs were saints. Ninth, some non-saints were martyrs. 10th, some martyrs were non-saints. 11th, some saints were non-martyrs. 12th, some martyrs were not saints. 13th, no saints were roommates. 15th, some martyrs were born as non-saints. G exercise. If some merchants are not pirates is true, what may be inferred about the truth or falsehood of the following propositions? That is, which can be known to be true, which can be known to be false, and which are undetermined. First, no pirates are merchants. Second, no merchants are non-pirates. Third, some merchants are non-pirates. Fourth, all merchants are pirates. Fifth, some merchants are non-pirates. Sixth, all merchants are pirates. Seventh, no merchants are pirates. Eighth, no pirates are non-merchants. Ninth, all non-pirates are non-merchants. 10th, some non-pirates are not non-merchants. 11th, some non-pirates are merchants. 12th, no non-pirates are members. 13th, some pirates are merchantaries. 15th, no merchants are or pirates.